Derivative of a linear by first principle. The power of x is power of 1. That's why it's called linear. That's the highest exponent. Pick a point here. That point will be x and y. So if I trace that down, that's x. That's the y value. And if I pick a point there, if I trace it down here, that will be x plus delta dx. And if I extend that point to that will be y plus dy. So this point has a coordinate x plus dx, comma, y plus dy. Now, what that meant is the distance between these 2 points here is dx. So that distance is dx, because that's dx plus x. That's that. And the distance between these 2 points here, this point here is dy. So that's dy, that distance and that distance. And we know what gradients are. Gradient is dy over dx. We know y equals ax. I'm increasing y. I'm also got this, that's for this point here. But what about for that point? That will be y. For this point here, it's y plus dy will be equal to a, open bracket, x plus dx. So at this point, that's that point there. This point here, that's this point here. All I did was the y changes here, that's just y, and that's just x. And when I got here, I don't just have y, I have y plus dy. So that's y plus dy. And at this point, I've got x, not just x plus dx. Now what I need to do is expand this bracket. Y plus dy equals ax plus a dx. Now, what I need to do is take y to the other side. So I get dy equals ax plus a dx minus y. But we know what y is. Y is ax. So dy equals ax plus a dx minus ax. As you can see, ax, we cancel each other because that's plus and minus. And I'm left with dy equals a dx. So I need to divide both sides by dx. So dy over dx equals a dx over dx. Therefore, the x over the x cancel each other, and then I just get dy over the x equals a. So if I'm differentiating or finding the gradient of that linear, it's always going to be the constant next to the linear. For example, you don't need to draw the graph to actually do the calculation, to do the derivative. Now, if I have y equals 3x, and I'm differentiating that, that will be y plus the y, because I'm changing that, I'm adding the y to it. I have to add the x to it, because I've added the x. At that point, I also add the y, because I'll change from there, from y to the y, from x to the x. So this will be 3, open bracket, x plus dx. In some books, the x is called h. So you will see h here. H equals the x. So watch out for that. H and the x are the same thing. Let's just call it h. And now what we need to do is expand this bracket. So y plus dy equals 3x plus 3 dx. Now, what do we need to do? We need to take y to the other side. So we get dy equals 3x plus 3 dx minus y, but y is 3x. So the y equals 3x plus 3 dx minus 3 dx. Well, you can see that 3x, we cancel 3x. Sorry, that's 3x, by the way, minus 3x. The y equals 3 dx. And divide both sides by dx. So the y over dx equals 3 dx over dx. Therefore, the y over the x equals 3. And that's your differential. If you differentiate y equals 3x, you get just 3. So that's what we just derived there. So if you differentiate y equals ax, you just get a. And that's the derivation from first principle. As I said, people use h instead of the x. So you would see the y dx will be, this is the formula that people use. The people use this formula, they just say, it's the same thing. They'll say y plus the y minus y over, I've done over twice, excuse me, over the x. And you can see that y minus y, if you expand the bracket, you'll get y minus y, that's just minus plus the y over the x. And you can see that will become, because y we cancel y, which is what we've done here, y cancels y. And then you just get your dy over the x. So that's the what you see people using. And y minus y, sometimes this is written as f of x plus the x. That's what that y plus the y is. And y is always f of x, right? And you're dividing it by dx. So that is the formula people are using. And that's the top here. In retrospect, when you're finding your differential equation, the x is always called h. So this one is called h. So you might see people write that down as h. So don't forget that it's minus there. So that's minus, and you then divide it by the x. As I said, some people use h as well, so they might just divide it by h. So it's a very common formula that it's been put out there for the first principle. So the formula will be, but you have to use the word in the limit. We don't need in the limit here because this is linear. So we just basically finding the gradient. So we don't need in the limit here because we don't have to limit the shape of the graph to make it look more linear. Because in the limit is used when you're doing curves. But so if you, this is a formula that's been put out there. So f of x plus dx, or sometimes they might say delta x, that's a small change, minus f of x, which is what you've got here. That's because this one is called delta y, that means it's called delta x as well. So that's that point that we're writing there. So f of that minus f of that to get that height. And you divide it by the height, the width here. And you divide it by the width here, which is called, again, which is delta x. Delta means small change, that's a small change. And we tend to say that will give you delta y over delta x, in the limit that delta x tend to 0. That means as that distance, that little distance gets smaller. So we're going to do that next when we do curve. So that's the formula that it's been thrown out there, and that you cannot use dy dx. You can only use dy dx once you've done your limit. And then from there, you're not qualified to use dy dx. And then you can say, after you've done in the limit, you can divide that. Then you can say dy dx equals to whatever value you get from there.